All right, why don't we have a word of prayer, and maybe I can just give you a short recap of what we talked about last time for those of you that were new, and we'll get into our new topic. Okay, so let's pray. Our loving Heavenly Father, thank you so much for this youth conference, this time for us to just grow, to get to know you better. And I pray for each and every young person here that you would be leading in their lives, that they would just be surrendering to you, and that you would be leading evidently every step of the way in the decisions they're making, and just everything in their life they would be turning to you, Lord. And Father, as we're studying this important topic of creation, I pray that it would make sense, it would be clear to the students, and that ultimately we would be able to defend our faith, we would be closer to you, and see your goodness in the things around us. I pray that you would help us, help me to speak clearly, and that this session would just be a blessing. I pray these things in Jesus' name. Amen. All right, so last time, for those of you that missed it, we basically went through why you cannot be both a Christian, saying that you believe in the Bible, and an evolutionist. You can't mix the two, creation and evolution. They're totally different. The order is different, if you will. And so you really have to choose one or the other. Jesus believed in creation and a worldwide flood, and so does Sister White, and I think that's good enough for what Jesus did. So then we talked about some of the theological implications. If you do believe in evolution, you have to throw out the story of Adam and Eve and the fall and sin and death. It's not the wages of sin anymore, and really why do you need a Savior if there was no Adam and Eve and the temptations of Satan and the fall. Okay, and there are probably some other things, but let's go into our new topic. Oops. Push the wrong button. There we go. Alright. So, the debate within the world. Okay, these names I kind of came up with before I knew exactly what I was going to be talking about. But basically the debate within the world, we're going to look at evidence for a designer, evidence for a creator that we lovingly know of as God. Okay, so the debate within the world. Alright, so what is faith? Okay, faith. Here's a few definitions of faith. The Bible tells us that faith is the substance of things hoped for, the evidence of things not seen. Where's that located?
Hebrews 11 verse 1.
Hebrews 11 verse 1. Good. The faith chapter of Hebrews 11:1. Faith is the substance of things hoped for, the evidence of things not seen. So there's evidence, but you haven't actually seen something occur. The Bible calls that faith. The dictionary says faith is the confident belief or trust in the truth or trustworthiness of a person, concept, or thing. So you believe there is some trustworthiness to something, you can have faith in that person, concept, or thing. Humanistic view, so naturalistic, humanistic, not talking about God. Someone would say the faith is the belief in something that does not find evidence in the natural world to support its claims. The opposite of a scientific observable fact. So when a scientist, an evolutionist would say, you have faith, and they're going to look at that as a negative thing, meaning there is no scientific evidence for what you are believing in. And I see some of you craning your necks, but I'm not sure my eyesight is good enough to back up too much further. Okay, so those are some definitions of faith. Now, what is science? Okay, unlike a mathematical theorem, science, or the scientific theory, is empirical, meaning it should be anyway always open to be falsified, okay, or falsifiable, meaning when we do science find out, we're trying to really prove something wrong. And then if we can't prove something wrong, we eventually say it must be true. Okay, does that make sense? So you're trying to prove something wrong, or actually prove is not really a word we use in science. But you're trying to falsify something. And if you cannot show that it's false, then it must be true. It's basically how science works. So then, no theory is ever considered strictly certain as science. Works under a fallibilistic, is it? Okay, fallibilistic view, meaning it can be falsified, it can be shown to be not true, and therefore it would need to be changed. Instead, science is proud to make predictions with great probability, bearing in mind that the most likely event is not always what actually happens. But probabilities is something we use a lot in science. So it's most likely this is going to happen. You know, when you give plants enough soil and water and sunlight, most likely what's going to happen? It'll grow. And if you take away the sunlight, what will happen to the plant? It will die. Okay? Probably. I mean, is there a small chance the plant can keep living without sunlight? Maybe. But usually it's going to die. Okay, so that is science. Scientific method, seeking to explain events in nature in a reproducible way. That's an important word. It's a reproducible way. So that you can actually do the experiments multiple times if need be. Okay, and then using these findings to make useful predictions. So again, you know, the plants, if you test the plants and they do really well at a pH of 8, you can over and over, you can put on a little tag. You know, when you buy this plant, give it a pH of 8. Right? That's using science to make a useful prediction. Okay, we do science by making observations around us, looking, seeing what happens in the natural world, making observations, then making a hypothesis, an educated guess of what would happen if you did certain experiments. Then you actually test the hypothesis, okay, making predictions from what you were able to test, whether it was falsified or not. Okay, you do the experimentation, and then this method can be repeated until you come up with a model, okay, a reproducible model to explain the observation. Okay, that's how the scientific method works. And if the hypothesis is shown to be true, then you keep it. If the hypothesis is shown to be false, then you throw it out and start over again. All right, get a new hypothesis. All right. So then, I hear people say, evolution is just a theory. We shouldn't take it seriously because evolution is just a theory. Well, that's not an acceptable response, actually, because hypotheses are those educated guesses that you start with. They haven't yet been tested over and over again. Okay, just looking at certain phenomena, making a guess. It's something that is possible. Make a hypothesis, it could happen. It's possible. Theory, then. Theory has been tested quite a bit. And has not yet been falsified. It has not been shown to be untrue. So something that is a theory, a scientific theory, becomes probable. And obviously it was not a Christian creationist that said that evolution is probable. But the scientific community thinks so. So saying evolution is just a theory, we don't have to take it seriously, is not a good response. And theories really carry quite a bit of weight. And then, if that, what my husband's singing. That's nice. If that theory then has been tested over and over and over again and has never been shown to be false in any situation, then we call it a law. Okay, a scientific law, like the law of gravity. Right, no matter what, here on Earth we have gravity. That is a scientific law, and there are not too many scientific laws out there. And that is certain. Okay, we are certain about gravity. Another one down at the bottom is the cell membrane. Okay, we've looked at it, tested it. We are quite sure what the cell membrane looks like and what it's made out of. So that is a scientific fact. Okay, so then, faith in evolution. So scientists claim to be totally unbiased, only going by the facts. They don't put their own information in there. Well, we're going to look at that to see if that really is true. They'll say something like, well, you have faith, I have science. You have faith, I have science. And they're totally different realms. Okay, and remember we talked about the definition of faith, you know, the evidence of things not seen. So you tell me, should evolution fall into this category? Has anyone seen evolution? Did anyone see the Big Bang happen? Did anyone see, apes turn into human beings? Okay, so I would call that faith. Okay, or the first living cell. That is just so way out there, not scientific in the least bit. That non-living molecules could self-assemble into a replicating living cell. I mean, that is so far-fetched. But yet, they will not admit that it takes faith to believe in that. But would you agree it takes faith to believe in that? Believe in the Big Bang? Believe in new hominid evolution of humans? Yeah, I would say that's faith. Plus, are any of these things reproducible or able to be replicated? Can you replicate the Big Bang and test it? Can you replicate apes turning into humans? Or cells coming from non-cells? No, okay, so it's not able to be reproduced. We didn't see it happen, so really evolution falls into the faith category, whether they like it or not, and they don't like it at all. Okay, you'll also hear people say, well, no thinking person believes in God. That you have to be ignorant, stupid, backwards person to believe in God. Well, that's not true at all. Back in '97, I actually need to look and see if there's something more recent. But in '97, the journal Nature, which is one of the best scientific journals out there, they did a survey of scientists. And they found out that 40%, okay, 40%, that's 4 out of 10 scientists, do believe in God. And that's a pretty high percentage. You can't say no scientists believe in God. It's actually quite a bit, 40%. That's close to being half. Physicists, biologists, mathematicians, they acknowledge that they believe in God. And if I had to guess, I don't believe this number would actually be higher now. Because even since '97, I mean, looking at the cell, how complex it is, looking at our universe, how organized it is, it's hard to look at those things and not believe in a creator, designer, God. One such individual is Anthony Flew. Anthony Flew was the atheist, I mean the foremost atheist in these years here, so the 20s. And he just died this year in 2010. But he was like, totally believed in Darwinian evolution, did not believe in God at all. But he became a theist, so he developed a belief in God through this intelligent design movement. It's called teleology, but intelligent design, you've heard of that before, right? Yeah, intelligent design basically says that you can look at our world and there's evidence for a designer because it is so just intricate and complex and it all works together so beautifully, so there must have been a designer. And specifically with Anthony Flew, one of his students asked him, okay, so if DNA is responsible for making proteins, right? Have you heard that before? DNA is responsible for making proteins. However, in order for that process to happen, there's lots of proteins that are involved in transcription and translation. Okay? Proteins are needed to make proteins. So they were like, where did those proteins come from before there was DNA to So because of that, and just looking at the complexity of the cell, looking at our worlds, looking at the design, he became a believer in God. Okay, that would kind of be like a Richard Dawkins, if you know him. He's like, or Stephen Jay Gould. He's dead now, but these are foremost atheists of our time. One of them becoming a believer in God. All right, the universe had a beginning. This is very interesting. So this is written more from the perspective of evolutionists, talking about the Big Bang. Okay, oh, that's really small. All right, I'll move it over here. Okay, so the options open to scientists are as follows. The universe was supernaturally created some 10,000 years ago, which is what we would believe, or even 6 to 10,000 years ago. Or the universe was supernaturally created some 10 billion years ago. Okay, so it's like supernaturally created or supernaturally created. For this reason, many atheists, cosmologists, those are the ones studying origins of the universe, cosmologists studying the origin of the universe. Many atheist cosmologists have also opposed Big Bang cosmology because if there was a beginning, then there must be a beginner. So they're used to think, these atheist evolutionists used to think that our universe has been around forever. The universe did not have a beginning. But from looking at the universe is actually expanding. So looking at that and other things about our universe, that almost everyone has come to the conclusion that the universe had a beginning. They want to call that beginning the Big Bang, but they're saying the universe had a beginning. So, I mean, the atheists were fighting it tooth and nail. They were trying to find any way to say that the universe did not have a beginning, because if there was a beginning, there should be, by definition, a beginner or something, someone to start the whole thing. So an information theorist named Hubert Yockey notes that the results of these implications have been that in spite of other successes of the general theory of relativity, the Big Bang, and in particular the idea that the universe had a beginning, was fought bitterly every step of the way. Okay, so the atheists did not want the universe to have a beginning because that has implications. Einstein himself had trouble accepting his own theories with his worldview, as they showed the necessity for a beginning and the presence of a superior reasoning power. So at the beginning, there's a reasoning power to start it all off. To avoid the consequences of his own theory of relativity, Einstein added a cosmological constant to the equations to change its philosophical implications, to avoid the necessity of a beginning to the universe. So in order for Einstein to avoid the implications of a God beginning the universe, he added to his equations a cosmological constant, okay, so that God wouldn't need to be there. Decades later, after the cosmological constant was disproved, Einstein called the addition of the constant the biggest blunder of his life. So he tried to tweak the evidence, tweak his theory so that there would not need to be a God, and found out that that was the biggest blunder of his career, of his life, actually. Sir Arthur Eddington, an astronomer contemporary with Einstein, wrote, "Philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole, and admitted that unscientifically I feel unwilling to accept the implied discontinuity in the divine nature caused by the Big Bang creation event. But loopholes weren't to be found, and cosmologists who once strongly held to an infinite universe without a beginning, most for philosophical reasons, they didn't want to accept the universe had a beginning, and that leads towards God, today are few in number. This led scientists of Einstein's day, such as Nobel Prize winner Arthur Compton, to say, "For myself, faith begins with the realization that a supreme intelligence brought the universe into being and created man. It is not difficult for majestic statement ever uttered. In the beginning, God. Okay, and this again is not some backward individual. This was a Nobel Prize winner saying that in the beginning, God were the most majestic words ever spoken. And the universe points to a creator God. Okay, more evidence for a designer. British astrophysicist Fred Hoyle writes, a common sense interpretation of the facts suggests that a superior intellect has monkeyed, and I'm not sure why I used that word, but there was a superior intellect that monkeyed or tweaked with physics as well as with chemistry and biology, and that there are no blind forces we're speaking about in nature. The numbers one calculates from the facts seems to me so overwhelming to put this conclusion almost beyond question. So he looks at biology and chemistry and physics and says, everything is so orderly, there has to be a designer. The anthropic principles, I love these, so I put a lot of them in here. Anthro is for man, and the anthropic principles basically say that the universe is so balanced. It's called balance on a razor's edge. I mean, how thick is a razor? Really thin, right? If you were to balance something on a razor's edge, it would be just barely hanging on, right? So the universe is balanced on a razor's edge, meaning that if a lot of these forces, like gravity and the nuclear forces, and some we'll talk about, if they were off just a little bit, there would be no man. So the very fact that life is here and that man is here, it looks like the universe was designed just for us. It's perfect. Anthropic principles. It looks like the universe was designed for man, that the universe had man in mind, is another way to put it. Alright, so let's look at a few of these. So, there's background radiation in the cosmos, okay? In the universe, there's background radiation, and if that was changed in 1 part in 10 to the 5th, that's 100,000. So if we change just 1 part out of 100,000, either plus or minus with this background radiation, the cosmos would exist exclusively as gas. You wouldn't get solid matter at all. Stars, planets, and galaxies would not exist. If the factor were increased slightly, the universe would consist only of large black holes. Either way, the universe would be uninhabitable. If that background radiation was changed, just 1 in 100,000, a small little change, there would be no life on this planet. Another one has to do with the nucleus of the atom. Okay, you guys have studied this before? Atom over there. There's the protons and the neutrons. Notice the protons are the blue ones over there, and the neutrons are the red ones, and then the electrons are zooming around outside the nucleus. Okay, the protons and the neutrons are held together by something called the strong nuclear force. Okay, the strong nuclear force holds the protons and the neutrons together. Okay, so the strong nuclear force that holds the atoms and therefore matter together. The sun derives its fuel from fusing hydrogen atoms together. When 2 hydrogen atoms fuse, 0.7% of the mass of the hydrogen atoms is converted into energy. If that amount, that 0.7%, if that amount of matter converted were slightly smaller, let's say 0.6%, instead of 0.7, a proton would not be able to bond to a neutron, and the universe would consist only of hydrogen. So you wouldn't have anything else in the universe except hydrogen. Without the presence of heavy elements, planets would not form, and hence no life would be possible. Conversely, if the amount of matter converted were increased to 0.8%, not a big jump, right? 0.8%, instead of 0.7, fusion would occur so rapidly that no hydrogen would remain. And the result would be no planets, no solar systems, and hence no life. So just a little change, either smaller or bigger, in this strong nuclear force, you would not have life, you would have no planets. ratio of electrons to protons must be finely balanced to a degree of 1 part in 10 to the 37. That's a 1 with 37 zeros. Okay, that's huge. Huge number. So just 1 in that big of a number that was changed. Because really, if there was a Big Bang, there was no God, things just happened completely on their own, is there any reason that the number of protons would have to be equal to the number of neutrons? No, or sorry, protons and electrons. Now what charge do protons have? You guys remember? Positive. What charge do electrons have? Negative. Okay, so they balance each other out, the positives and the negatives. If there was a Big Bang, is there any reason that we wouldn't have twice as many protons than electrons? No, or twice as many electrons than protons? No, but they're equal. They balance each other out. And what's not in here, what's also really interesting, what's the size difference between them? Protons are way bigger than electrons. It's like 1,300 times bigger. The proton is like 1,300 times bigger than the electron. But they have the same net charge. So even though the proton is 1,300 times bigger, it has a 1 positive charge. And even though the electron is 1,300 times smaller, it has a negative 1 charge to balance each other out. There's no reason that that should have been like that if everything was just random from a Big Bang. Alright, so this is off in 1 part in 10 to the 37. If it were any larger or smaller, then electromagnetism would dominate gravity, preventing the formation of galaxies, stars, and planets. Again, life would not be possible. The rate at which the universe expands, so the universe expanding is finely tuned at 1 part to 10 to the 55, so that's 1 with 55 zeros after it. And it's just tiny, tiny. You can't even imagine how close a change would be. Okay, if the universe expanded too fast, then it would be too quickly for the formation of any planets or stars or galaxies. If the universe expanded too slowly, the universe would quickly collapse before the formation of the stars, or even now, it would just collapse in on itself. Or if it's expanding too rapidly, you wouldn't get any planets, we wouldn't be here on planet Earth. Alright, when you turn your radio, there are certain frequencies where the circuit is just right and you get resonance. Okay? Think of this as like waves. Okay? What resonance is like waves. And you lock into a station. The internal structure of an atomic nucleus is something like that, with specific energy and resonance levels. If 2 nuclear fragments collide with a resulting energy that just matches a resonance level, they will tend to stick and form a stable nucleus. Behold, cosmic alchemy. Blending 2 things together will occur. Now, in the carbon atom, the resonance just happens to match the combined energy of the beryllium atom colliding with a helium nucleus. Okay, beryllium being 3 and helium 2. Carbon is 6. Maybe beryllium is 4. Anyway, okay, so beryllium, I think boron is 3. So beryllium with 4 protons combines with a helium. There's 2 protons to make up a carbon that has 6 protons. Atomic number 6. Okay, so beryllium combines with helium to form carbon. Without it, there would be relatively few carbon atoms. Okay, so if there wasn't this resonance between those 2 that they would combine, then we'd have no carbon atoms. Similarly, the internal details of the oxygen nucleus play a critical role. Oxygen can be formed by combining helium with carbon. So carbon again is 6, helium is 2, and that gives us our atomic number 8 for oxygen. Okay, oxygen can be formed by combining helium and carbon nuclei, but the corresponding resonance level in the oxygen nucleus is 0.5% too low for the combination to stay together easily. Now, if they combined really easily, then all the carbon and all the helium would turn into oxygen. Does that make sense? All the carbon, all the helium have no carbon. Anything that's organic is made out of carbon. Okay? Everything living is made of carbon. So if everything was oxygen and no carbon, there would be no life. If then they, you didn't get oxygen, if carbon and helium never wanted to form oxygen, then you wouldn't, have life that way either without the oxygen. I put some examples up here. Up at the top there, that's an amino acid, the building blocks for proteins. Carbon, you have to have carbon, and oxygen to get amino acids. There's DNA. Okay, DNA is made out of carbon. There's glucose, which is made out of carbon, oxygen. So you need to have those. And again, if there was just a big bang, no God, no design, there's no reason that we would have carbon and oxygen in order to make all these organic molecules and us. Okay, a couple more here. Chemical laws present from the beginning of the universe also show that water, is water important to our planet? Yes. Yes, it's vital. We have to have water for life on this planet. Chemical laws show that water, the basic molecule of life on Earth, has very unique properties which any different wouldn't allow for life on Earth. Liquid water is probably vital to any carbon-based life form. Water is also vital due to its properties as a liquid solvent. So water is used to dissolve other things. Okay, and that's why your blood is so important. The water in the blood dissolves sugars and salts and carries waste out of the body. So water as a solvent is necessary for life. However, if water was just a little different, it couldn't be this powerful liquid. Hugh Ross notes, who's a scientist, Hugh Ross notes that the rules of water chemistry are also fine-tuned, noting that polarity of the water molecule is greater, and the polarity, basically oxygen, the oxygen molecules are attracted to the hydrogen molecules of water, and the hydrogen are attracted to other oxygens of the water. So they stick together. When water spills on the floor, it forms puddles, right? Because water likes to stick to itself. Okay? That's because of the polarity of water, the charge difference. So because of this polarity of the water molecules, they tend to stick together, meaning, so the heat of fusion, that's the boiling point. Okay? The boiling point of water is very high. And vaporization. Heat of fusion would be melting then. Okay, the melting point and then vaporization is the boiling point. So those are very high compared to other things like nitrogen. You ever seen liquid nitrogen? Liquid nitrogen has to be super cold to even be liquid. As soon as liquid nitrogen gets in room temperature, it evaporates like that. Okay, whereas water, what's the boiling point of water? 100. Yeah, 100 degrees Celsius. That is very, very high. If the boiling point of water was not that high, then all the water would be gas, so we wouldn't have liquid water. Okay, so then, more about water. This is really interesting, you guys. You may not have thought of this. Water, when it freezes and turns to ice, is it more or less dense than liquid water?
Less.
Less. Your ice cubes in your glass, where do they go? Top or the bottom? Top. The ice cubes float in the glass. So the frozen water, which is solid water is actually less dense than liquid water. It's the only liquid that's like that. The only substance that's like that. Usually when things freeze and turn solid, they become more dense and they sink to the bottom. But water is different. Water, when it freezes, is less dense and stays on the top. What would happen to our oceans if water, once it froze, sank to the bottom? The whole ocean would freeze over. Okay, when it got real cold, it would freeze, sink to the bottom, and the next layer would freeze and sink to the bottom, you'd basically have everything dying in the ocean, in the cold parts of the ocean. Okay? They would die. So then, so Earth's ocean would freeze from the bottom up. So these other two physicists and mathematicians explain this is highly uncommon. Okay, they're saying that water is one of the only things that does this. And because of that, we have surface tension, the specific heat, other physical properties. So the specific heat is talking about how much heat you have to put into water before it actually turns hot. Okay, that's why on a summer day, is it nice to jump in a pool or the ocean? Why doesn't the water get just as hot as the air or the ground? How come the water stays cool? Yeah, it's because of these properties that water has. You can put a lot of heat into water before the temperature actually goes up, so it stays cool even on a hot day. Okay, so then, and that makes it useful for liquid of living things. Okay, so then, the distance from the Earth to the Sun. So if that was different than water, if we were too close to the Sun, then all the water would boil. We wouldn't have liquid water on this planet, and we obviously couldn't have life as we know it without liquid water. If we were a little further away from the Sun, Earth was further from the Sun, then all the water would be frozen. Yeah, exactly right. And we wouldn't be alive on this planet. So, it seems that the designer influenced the fundamental properties of the universe, like where the Sun is in relation to the Earth. Alright, so not just where the Sun is in relation to the Earth, but where our Sun and Earth are, our solar system, in the galaxy. Okay, what galaxy are we in? The Milky Way galaxy. So we are positioned in a disk in the Milky Way, about halfway to its edge in between two spiral arms. So you see these spirals of the galaxies, and we're in between two of them. We know now that the structure of the galaxy is preferred to others. If our solar system, okay, our Sun and its planets, were closer to the center of the Milky Way, or closer to one of the spiral arms, we would get too much radiation and from the clouds, so that, again, all the water would be boiled up, we would be bombarded with the radiation. If the solar system was further out in the Milky Way, then there wouldn't be those heavy elements to build a planet capable of supporting life. So it's not just the nuclear forces, it's not just the whole universe, it's like we're in the right house, in the right neighborhood, in the galaxy in order to have life. Okay, so then, our solar system's position remains constant. There are some suns that actually move in relation to their galaxies. Our sun doesn't do that. Okay, if the sun moved, then it would get too hot, too cold. We could not have life on the planet. Okay, and then our sun, most textbooks discuss the sun as if it were a typical star. It is a more massive star than 90% of the stars in the Milky Way. So out of all the stars in the Milky Way galaxy, our sun is actually one of the biggest ones. Okay, so we could have been stuck with a real tiny sun that wouldn't have given us any warmth and not had, all the water would have been frozen and not had life. Okay, the sun is anomalous or different in other ways, including its composition, the brightness, the orbit, and it all argues that these characteristics must be exactly as it is for advanced life on Earth to exist. Liquid water is necessary for carbon-based life, and probably for any life. Yet, another parameter allowing for life on Earth is its position within the solar system, allows for liquid water. Okay, I think I already mentioned this one. Okay, so if we were further away from the sun, it would all freeze. If we were close to the sun, it would all evaporate away. The moon. Have you ever thought about what it would be like with no moon? If we didn't have a moon, what is the moon responsible for? The tides. Yeah, the tides. So if there was no moon, we would not have the tides, and therefore the oceans would turn stagnant. Okay, have you seen stagnant pools that mosquitoes like to breed in and algae grows in? All the oxygen gets used up and it's just a death pool. Okay, so our oceans are churned with the tides, and that keeps them oxygenated and living. Okay, with the moon. Okay, and then the size of Earth itself. So if Earth was a little bigger or a little smaller, the radiation, okay, or the magnetic field of Earth protects us from harmful radiation. So if the Earth was smaller, we wouldn't be protected as much from the harmful radiation. We have plate tectonics and volcanoes bringing new magma to the surface. Okay, so, and again, it shows that God cared about life on this planet because the Earth is the right size. So we're the right planet in the right place. Okay, this physicist says that the temptation, okay, he actually uses the word temptation, that he feels a temptation to believe that the universe is the product of some sort of design, a manifestation of subtle aesthetic. The beautiful aesthetic is beautiful. Subtle beauty and mathematical judgment is overwhelming. The belief that there is something behind it all is one that I personally share with, I suspect, a majority of physicists. So when the physicists look at the world, he can't help but feel that this world is beautifully designed. And he calls it a temptation. So it probably means he doesn't believe it. He chooses to reject that just because of his evolutionary ideas. Okay, so Sir Fred Hoyle, we saw a quote from him earlier. He stated that the chances, remember science is all about probabilities, the chances of evolution actually being true would be like a tornado going through a junkyard and assembling a perfectly running 747 jet. Okay, an airplane, a tornado going through a junkyard, putting all the pieces in the proper working order, like it's ready to be taken off, got fuel in it and everything, from a tornado. Would that ever happen? No, I don't care how many billions of years you give the tornado. It's not going to perfectly assemble an airplane. It's going to tear apart some things. It's not going to put them together. But this is why the evolutionist himself says. But because of this preconceived idea that it had to have happened, he says it had to have happened, even though it's so totally unlikely. Oh, actually, go back. All right, I wasn't able to get any videos in my PowerPoint. Let me show you. In a movie called Expelled, have you heard of that before? With Ben Stein, have you seen it? It's really quite good. It's a documentary on individuals that basically have been persecuted for not believing in evolution. Where do I want to go? I want to go to my videos. Oh, that was good. Yeah, that'll be tomorrow. Okay, Expelled. So, I'm going to need a about from non-life, right? From just organic molecules self-assembling into a cell. life from non-life, that they might have, these molecules might have attached themselves to crystals and somehow formed a cell. Not very scientific if you ask me. Okay, so that individual, Richard Dawkins, he wrote The Blind Watchmaker as well as a refute against intelligent design. He's quite, making a lot of money off his atheism. Anyway, he suggests that given enough time that anything can happen. Now, if you give 4.5 billion years since this planet supposedly formed, that anything can happen. He says that if you take, this is called the infinite monkey theorem. So if you can take 1 million monkeys, we're given typewriters. Give 1 million monkeys typewriters and let them just whack away on typewriters for millions of years, that one monkey would eventually type one of Shakespeare's sonnets. Okay? Perfectly type one of Shakespeare's sonnets. If you have enough monkeys and enough time, it would eventually happen. Well, the British National Council decided to test this. Okay, so they didn't have 1 million monkeys, but they started off with 6. Okay, 6 monkeys, they gave them a computer, not a typewriter, and they gave them 1 month in the room with this computer. Okay, so guess what happened? The monkeys typed 50 pages. They really liked the S key for some reason. They also used the computer as a toilet. But guess how many words they typed in a month's period? And on those 50 pages, how many words were there? None. They didn't type a single word. Now, what's the smallest word in the English language? A or I, right? But there has to be a space, a space, right? Or a space, I space. The monkeys didn't even do that in a 1 month's time period. So obviously this is too small of an experiment to just totally discount the theory, but it got people thinking. Like, let's actually calculate the probability of the monkeys being able to type one of Shakespeare's sonnets. So they did. Hey, this man, Schroeder, he said every one of Shakespeare's sonnets is by definition 14 lines long. Okay, 14 lines long. He chose one that he liked. I think it was "Shall I Compare Thee to a Summer's Day." It has 488 letters. Okay, 488 letters to this sonnet. And he wanted to know what are the chances that the monkeys would randomly type out these 488 letters. And let me just, as a side note here, say the cell is so much more complex. Okay, so much more complex than just a 488 letter sonnet. Remember the video said how many proteins would be needed for a cell, a simple cell? 250. Okay, 250 proteins. And by definition, a protein needs to have 100 amino acids. Yeah, so you're talking about 25,000 amino acids, okay, to be able to come up with those 250 proteins to have one cell. So that's a number way bigger than 488, right? So we're talking about simple here, 488 letters. All right, so what are the chances the monkeys would actually type out a sonnet? Well, it's 26, because that's how many letters are in the alphabet, to the 488th power, right? For every letter, there's a chance that it's going to be 1 in 26. You have to be 1 in 26 times 1 in 26, 488 times. Okay, that, if you change it to base 10, equals 10 to the power of 690. That's a 1 with 690 zeros after it. Okay, you can't even fathom a number that big. That's the chance that the monkeys would actually type out one of Shakespeare's sonnets. To break this down even further, the 10 to the 690, there's only 10 to the 80th atoms in our universe. Okay, not just on this country or in this planet, but in the universe, there's only 10 to the 80th. I believe that's supposed to say atoms, sorry, not electrons. Either way, okay? Okay, so that's 10 to the 690. near that many atoms in the universe. Or another way you could put it, and this is actually from Anthony Flew, that's atheist guy that was converted because of these probabilities. He says if you converted the universe into computer chips, the entire universe, again, not even just this planet, but the entire universe you converted into computer chips, weighing about 1/1,000,000th of a gram, and each computer chip able to spin out 488 trials 1,000,000 times per second. 1,000,000 times per second. Producing these random letters in order to try to get the sonnet. The number of trials you would get since the beginning of time. Beginning of time, not in a creationist perspective, in an evolutionist perspective, 4.5 billion years, or actually probably even more than that. Since the beginning of time would only be 10 to the 90th trials. Okay, from the beginning of time, every space in the universe was taken up by computer chips that are able to pump out 488 trials 1,000,000 times per second. You would only come out from the 10 to the 90th trials. That's off by a factor of 10 to the 600. So it's not anywhere close. And he goes on to say that just Schroeder. Okay, Schroeder was the one that came up with the number. Anthony Flew says that Schroeder has destroyed the infinite monkey theorem. There's no way the monkeys would ever be able to come up with this. Another way I've heard it is if you took a grain of sand, and say I wrote my name on one grain of sand, and I threw that grain of sand somewhere in the Sahara Desert, the entire Sahara Desert on the top of Africa. Okay, mix it all up, and I said, go find that grain of sand in the Sahara Desert. Let's say you somehow were able to get it when you pulled out the grain of sand. It was the one with my name on it. You would have to do that 5 times in a row in order for this infinite monkey theorem to be correct. Okay? It's impossible. Never, ever would happen. And remember, the cell is so much more complex than even one of Shakespeare's sonnets. You would never evolve a cell from nothing. Alright, there's some circular reasoning. We mentioned the DNA and the protein. Here's another one here with the ribosome. Okay, so DNA information requires a ribosome for transcription and translation to happen, but the instruction on how to build ribosomes is in the DNA. So it's like, which came first, the chicken or the egg here? Okay? You need ribosomes to get DNA, but DNA say how to make the ribosomes. Alright, Charles Darwin himself, when he wrote his book on the origin of species, we did not know very much about the cell. They basically thought the cell was this sack of goo. And a sack of goo is what the cell was to Darwin. He says that if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would completely break down. But I can find no such case. And that's what he thinks. Right now, the complexity of the cell. Now that we've looked at the cell, we can see is the most complex system machine that can even be fathomed. I mean, we can't build anything as complex as the cell. There's power stations producing energy needed by the cell. There's factories making the hormones and enzymes essential for life. There's a data bank where all the information is stored. There's complex transportation systems. There's actually little highways in the cell. There's laboratories and refineries breaking down materials into usable parts. The membrane of the cell is so highly selective for certain things coming in and out. I mean, Darwin didn't know any of this about the cell. And that's only a small part of how complex they are. It is one part of the cell that is super complex and interesting is called the flagellum. Okay, this is a bacterial flagellum. Okay, what is that for? You guys know?
For turbine.
Okay, so it's for movement. It spins, okay, and it's for moving the cell. Flagellum. It's what sperm have too. The flagellum requires 40 proteins to function. All 40 of them. So see all these be done together at one time for this bacterial flagellum to function. And if you take away just one of those proteins, the whole flagellum is non-functional. It doesn't work. It's called irreducibly complex. Okay, if you take away one piece, it's gone. Not going to work anymore. Basically, you would have this thing being drug around by the cell. There's no way that that would be advantageous to the cell. I have another video on this. So, it was Michael Behe. This is irreducible complex. Yes. Hold on, I'm not sure this is the right one. Okay. flagellum is so complex. I mean, it's a motor. It's like an outboard motor on a boat. And it's, as I said, it's the most efficient machine in the world that we know of. The flagellum can stop on a quarter turn. So, I mean, when you tell your motor to stop, does it stop that quickly? No, it keeps spinning for a while, right? So it can stop on a quarter turn and reduce, or reverse direction, start going the opposite way. And just so quickly. Amazing machine. Molecular machine, though. It's all made from proteins. And you don't have all 40 of them together, it does not work. Okay, so that's irreducible complexity. So that's one of the main proponents of the intelligent design movement is using irreducible complexity. So evolution says that things are built up slowly in small sections. But again, if you don't have everything together at that same time, then it does not work. Or the human eye. Now, the complexity of the human eye. If everything is not there together at the same time, your eye does not work. You can't slowly evolve an eye. Okay? Or blood clotting. You know, the blood clotting mechanism, it takes numerous proteins to work. And if they aren't all there, it doesn't work properly. Like hemophiliacs are missing just one protein, and they bleed and aren't able to clot their blood. Alright, so evolution's hall of shame. So this, I'm going to poke fun a little bit at the evolutionists. They state they are unbiased, they only go by the facts. Well, let's see what has happened in history and if that is really the case. Alright, there was something called the Piltdown Man. Okay, the Piltdown Man was discovered in 1912 by this Charles Dawson, so not Darwin, but Charles Dawson. It was an ape-like mandible with human-like teeth and a human-like piece of skull. So it was thought to be the missing link. It was half human, half ape. It's got to be the missing link between apes and humans. The front page of the New York Times said Darwin's theory proved true. The front page of the New York Times, once this skull was found, proved true. Okay, then in 1953, so that's 41 years later. 41 years later, it was proved to be a hoax. Okay, these guys looked at the skull and found that Piltdown Man was a complete hoax. It actually was half ape, half man, meaning they took an ape's jaw and put it with a man's skull and teeth. And they like put acid on it. It was fresh bone, but they put acid on it to look like it was fossilized. Okay, and this, notice how long this was, you guys. 41 years. This was scientific fact. You know, the missing link had been found. So if something comes out, you know, tomorrow where they have found the missing link between something, just weed it out. You know, science, true science, will be shown to validate God's word and not evolution. Alright, so anyway, for 40 years this was believed to be the missing link between man and monkey, ape. Alright, another one. So Nebraska Man. Nebraska Man was discovered in 1922 in Nebraska. That's why I got the man. And it was one tooth. So one tooth was discovered in Nebraska, and they drew that picture of this Neanderthal-looking guy and his wife from one tooth. They were able to draw that. That's pretty good, huh? Pretty good imagination, anyway. And from one tooth. They tried to use this as evidence in the Scopes monkey trial. That was a trial where a teacher wanted to teach evolution. Anyway, so this was going to be evidence in that trial. And those drawings up there were published in the London News in 1922 from this one tooth that was supposed to be the missing link in human evolution. Well, this turned out to be a pig's tooth. Okay, an extinct pig. Not even close to what they drew there for Nebraska man and the missing link from this tooth. Alright? So again, science biased? Yes. Okay? So yes, scientists can be biased, they make mistakes. Good science will turn up those mistakes, as I was telling Kenneth during the break. There have been discoveries of human artifacts that are in very old layers where humans were not supposed to have existed at that time. But because it doesn't fit with evolutionary theory, they have to throw it out. They have to throw it out and say, well, that can't be human, artifacts. It's not an axe head or whatever it was. Just recently, in this last year, we had Climate Gate. Were you guys aware of that? The whole global warming. Okay, global warming. There some emails surfaced that found out that the scientists were actually making up evidence for global warming. That they were totally changing the science to fit what they wanted it to say. Okay, that was called Climate Gate. So yes, scientists are biased. And unfortunately, they can take it to an extreme where they're really deceiving people. They're deceiving the public, not just being unbiased, but being deceptive. You like this down here? See the evolution of man to our computers? That's me. Alright, here's the website that I've been using for these talks. Detecting Designs. Write that one down. It's awesome. That's my friend, Dr. Sean Pittman. He works on this every week. So every week he does research on creation and evolution. He refutes arguments for evolution. So Detecting Design, you could spend a lot of time on there and get good information. And he doesn't, as one person said about Loma Linda, I went to Loma Linda for my master's degree, so I stopped with La Sierra. But I finished my bachelor's at La Sierra. I went on to Loma Linda for my master's degree in biology. And there, it's been said of some of my professors that are really good creationists at Loma Linda, they don't tell lies for Jesus. Okay, so there's no point in lying about creation evidence that isn't there, right? We want to be honest, look at the data. Anyway, so if you get an email that says that NASA discovered that if you take away a day because of, remember when Moses held up his arms during battle and the sun didn't set so that they could finish up the battle. And then with Hezekiah, and God turned back the sun 15 degrees for Hezekiah. They said if NASA puts those two things into the calculation, then it works perfectly or whatever. That's not true. It's fake. It's a fake email. Anyway, so don't tell lies for Jesus. And my friend Sean Pittman, who's a medical doctor but does amazing work with this, he doesn't tell lies for Jesus. Anchor Point Films is another really good. They make documentaries that are very artistic, defending our faith. They have lots of different topics. AnchorPointFilms.com. We have a few more minutes. Let me just do a couple. Another good resource you could write down is Creation Minute. CreationMinute.com, I'm pretty sure it would be. Let me show you a couple of these videos. These are made by Eric Hovind, and he's not an Adventist, but does good work. Okay, so he goes through some aspect of creation in 1 minute. Okay, this one has to do with the universe as well. Oh, never mind. Alright, shh. Alright, so the universe, the planets, our Earth is so tiny compared to the universe, yet we know that we are very special. We're the apple of God's eye. Okay, the order in the universe, how everything just comes together so perfectly, it shows that there is a God. The complexity of the cell, life originating from non-life is so unscientific. It's just the probability of it would never happen, ever. So I hope that you have learned something today. What I would do if I were you, I saw some of you taking notes, I think that's fantastic. If you took notes, I would go back through and maybe choose one or two things that you thought was just really the best evidence, what really resonated with you, that you could share with somebody else. If these issues ever come up, you meet someone that doesn't believe in God, I want you to have in your repertoire, your arsenal, ready to defend your faith. Okay, so pick one or two things that you want to commit to memory and say, wow, I'm going to use this anthropic principle, or I'm going to use, whatever that you thought was the most important from today. And actually commit it to memory and use it when you meet someone that is a skeptic, that doesn't believe in God. All right. Any questions from the material today? Anything at all? Was it clear? Yeah? Your faith affirmed that there is a God? That's good. Tomorrow, come back and join this session again tomorrow. We'll then go through, so I think we've established you can't mix creation and evolution. And tomorrow, and this one, there has to be a designer with the way the universe is. And then tomorrow, we're actually going to go through and see some evidence for a short chronology. Oh, and then scientists being biased. But tomorrow we're going to go through and see some evidence for a worldwide flood and for short time periods of this Earth's history and life on this planet. So that will be tomorrow, tomorrow's lecture. All right, well, why don't we have a word of prayer then? And you can have a few minutes to yourself. All right, good. Stand for prayer. Our awesome and powerful Creator God, I thank you so much that you have given us brains to be able to comprehend this universe, that the universe points to a God, and that our hearts just long to believe in a God. And I thank you that you have given us evidence of your existence, that you not only want to be our Creator, but you want to be our Redeemer and our friend. I pray that each person here would be turning to you in their tough times. They would turn to you for answers and for strength. And ultimately, God, that you would just be so close to us that we could feel your presence, we feel your loving care and your guidance in our lives. So bless each and every person here. Help them remember something from this lecture if they ever encounter someone that does not believe in you. And help them to affirm that person in faith in you. So bless us this evening and help us come back tomorrow for more information, and just this conference will be such a blessing to each and every person here. I pray these things in the precious name of Jesus. Amen.